Level 14, lecture number 4. So in this module, we'll be discussing all about fluid statics. Okay, so in particular, we'll be discussing about density, specific gravity, pressure, liquid pressure, Pascal's principle, and Archimedes principle. Okay, let's start with density. Okay, so density is defined as the mass per unit volume. So yung two most common units na ginagamit natin for density is gram per cubic centimeter and kilograms per cubic centimeter. Okay, so we have the following formula for density. So in density, we use the symbol rho, the Greek letter rho, to represent density. And then you have the mass over the volume. So, based dito sa equation, we can say that if you have high value for the mass, ganun din yung value ng density. So, the mass is directly proportional to the density. And the volume is inversely proportional to the density. Ibig sabihin, if you have high value for the volume, yung density would only have a small value. Okay, so inversely proportional. Okay, so let's look into the relationship between density and flotation. So, anong kinalaman ng density ng isang object sa paglutang niya? Okay, so for example dito, if the density of the object is greater than the density of the liquid, okay, so anong mangyayari? Lumulubog yung object. So, ang bigat ng object ay walang kinalaman kung lulubog ang object o lulutang. Kasi usually, iniisip natin na kapag mabigat yung object or pag mas mataas yung mass niya, lulubog siya sa tubig. But actually, it's not true. Kasi take for example yung barko. So bakit yung barko kung tutuusin mas mabigat naman talaga siya, 'di ba? Sobrang bigat niya pero bakit lumulutang siya sa tubig? So that principle has something to do with density. So sabi nga dito, lahat ay nakadepende sa density ng object at ng liquid. So kapag mataas ang density ng object kaysa sa density ng liquid, lulubog yung object natin. So for example, meron kang metal ball. Tapos, ang density ng metal ball mo is 3,000 kilograms per cubic meter. Mas mataas siya kaysa sa density ng water. Ang water kasi, for example, fresh water, ang density niya is 1,000 kilograms per cubic meter. So, since mas mataas ang density ng metal ball, which is 3,000, so obviously, yung metal ball, lulubog siya sa tubig. Okay? So, ito yung dahilan kung bakit lumulubog yung coin sa tubig. Di ba yung coin, actually, sobrang gaang lang naman niya. Pero kapag ginangis mo siya sa water, bakit siya lumulubog? Pero yung barko, lumulutang. Okay? Kasi yung coin, kung i-consider natin ang density ng coin, mas malaki ang density ng coin kaysa sa dun sa tubig, kaya siya lumulubog. Na paano naman pag meron tayong other scenario? So let's say this time, yung object mo naman, mas mababa yung density kaysa dun sa density ng liquid. Or in this case, you can say that your density for the liquid is greater than the density of the object. So again, inuulit ko, ang bigat ng object ay walang kinalaman kung lulubog ang object o lulutang. So kapag mas mababa naman ang density ng object kaysa sa density ng liquid, lulutang ang object. So ito ang dahilan kung bakit lumulutang ang barko sa tubig. Kasi kahit mabigat to, mas mababa ang density nito kaysa sa tubig, kaya ito lumulutang. So yun yung mechanism ng barko. Okay. So bakit ganoon? Eh di ba sobrang bigat ng barko? Oo, pero kung titingnan nyo, yung mass ng barko, hindi siya proportional dun sa volume ng barko. Kasi diba yung volume ng barko sobrang laki. Okay, kumpara dun sa mass niya. So, basically, sa loob, parang empty shell lang siya or very hollow siya. So, therefore, diba dun sa, remember dun sa equation natin ng density. Density is mass over volume. Ibig sabihin, kapag mas mataas ang volume mo kaysa dun sa mass, ang value ng density mo ay maliit. And paano naman kapag yung density ng object ay equal lang dun sa density ng liquid? Okay? So again, wala na namang kinalaman yung bigat ng object kung lulubog o lulutang ang object. So kapag same ang value ng density ng object at density ng liquid, ang tawag natin doon ay fully submerged. Ibig sabihin, yung buong katawan nito nandun sa ilalim ng liquid, pero hindi ito lumulubog at hindi rin naman to nakalutang. Kasi pag sabi mong nakalutang, may portion ng body niya na nakaangat doon sa level ng liquid. So in this case, parang siya, in between siya. Okay, so kaya sinasabi natin na fully submerged. In some text, minsan makikita nyo dyan, completely submerged. Minsan yun ang mga ginagamit na terms natin sa mga word problems sa physics. Okay, so let's look at this example. So dito meron tayong 4 different types of balls. Okay. So based dun sa way ng paglutang nila dito sa fresh water, okay, masasabi natin itong density ng golf ball is mas malaki kaysa sa density ng water. Why? Kasi if you notice, nakalubog siya. Sa kanilang apat, siya yung nakalubog. Ibig sabihin, mas mataas ang density nito kaysa sa density ng water. Now, ito namang baseball, mapapansin nyo, ito yung case na parang similar siya sa fully submerged. So, halos equal to. Okay. Although meron siyang maliit na portion nandito sa taas, pero ito yung pinakamalapit na example doon sa sasabihin natin na fully submerged siya kapag equal yung density ng object dun sa density ng water. And dito naman sa ping pong ball, ito yung nagpo-float talaga. Okay, so if you notice, sobrang liit lang ng portion na nandito sa ilalim ng water. So we can say na yung density ng ping pong ball is less than the density of water. Kaya siya nakalutang. Now, let's consider yung mga iceberg. Okay, so sabi nga, the water expands upon freezing by 10% due to hydrogen bonding. So, nag-expand ng water. Kung mapapansin nyo, limbawa pag gumagawa kayo ng yelo, tapos iba gumagamit kayo ng plastic, yung pang-yelo, o kaya ice candy. So, kapag nilagay nyo yan sa fridge, sa freezer, tapos naging frozen, kung mapapansin nyo, parang may stretch yung plastic, diba? Okay? Kasi ibig sabihin nun, yung water mo nag-expand na. Okay? Kasi yung water expands kapag yan ay ginawa nating frozen. So, the density of ice, okay, is actually 0.9 gram per cubic centimeter. Pag kinonvert natin to sa kilogram per cubic meter, this is equivalent to 900 kilograms per cubic meter. Kaya yung ice natin, nagfo-float siya sa tubig, pero 10% nung part ng ice is nakalutang. Okay? So, yung 90% ng ice is nakalubog sa tubig. So, kaya kapag nakakita tayo ng iceberg, 10% lang yung nakikita natin sa ibabaw ng tubig. Just like in this example. So, ito ay 10% lang. Yung remaining 90% niya actually ay nasa ilalim ng tubig. Kaya, di ba, sobrang delikado na mag-navigate through icy waters. Kaya, di ba, may mga regulations tayo dyan kung paano yung proper and safe navigation through icy waters. Okay, so let's have an example here. A wooden box weighs 10 kilograms and its dimensions are 1 meter by 2 meters by 0.5 meter. What is the density of the wooden box? So if the box will be thrown out in the water, will it float or sink and why? Okay, so sasagutan natin yan isa-isa. Okay, so first, ilista muna natin lahat ng given and the unknown quantities. So, you have the mass na 10 kilograms, and then you have the dimensions of the wooden box, which is 1 meter by 2 meters by 0.5 meters. And then, we will look for the value of the density. Kasi yun ang unang tanong, what is the density of the box? So, first, kailangan muna natin isolve yung volume. So, since given tayo ng dimensions, so, ang gagawin lang natin, multiply lang natin yung tatlong dimensions. So, you have 1 meter times 2 meters times 0.5 meter. So, you have 1 cubic meter. So, pag sinabi natin ng density, so the density is mass over volume. So, that's 10 kilograms over 1 cubic meter. So, therefore, you have a density of 10 kilograms per cubic meter. Okay, so therefore, the density of the wooden box is 10 kilograms per cubic meter. Now, next question, if the box will be thrown out in the water, will it float or sink? Okay, so, ano yung density ng water? So, kung sa water yan, ang density ng water is 1,000 kilograms per cubic meter. It's very important to remember this constant kasi madalas nyo yung may encounter. Pag fresh water, that's 1,000 kg per cubic meter. Kapag naman salt water, that's 1,025 kg per cubic meter. So, in this case, the box will float. Okay? Bakit? Kasi, yung density ng box is only 10 kilograms per cubic meter. So, which is less than the density of water, which is 1,000 kilograms per cubic meter. Okay, let's have another example. So, the spherical metal ball has a diameter of 0.3 meter. If the density of the metal ball is 150 kilograms per cubic meter, what is the mass of the metal ball? Okay, so again, susulit muna natin lahat ng given and unknown quantities. So, we're given with the diameter, which is 0.3 meters. So, pag kinuha natin yung radius yan, i-divide lang natin by 2. So, we have 0.15 meters. And then you have a density of 150 kilograms per cubic meter. So, we're looking for the value of the mass. So, isolve muna natin yung volume ng ball. So, katulad nga kanina, di ba, nabanggit ko na kailangan nating, since diameter ang given, kailangan natin munang makuha yung radius. Yan. So, kaya ang gagamitin natin dito sa pag-solve ng formula ng volume, okay, ng spherical metal ball is, ito, yung radius ng 0.15 meter. So, using the formula for the volume of the sphere, so you have 4/3 pi r cube. So, substitute lang natin. Gagamitin natin yung 3.1416 as the value of pi. Okay, so pag sinubstitute natin yan, we will get a value of 0.02 cubic meters. That is for the volume of the spherical metal ball. So, next, gagamitin na natin yung density equation para ma-solve yung mass. So, since we know that the density is equal to mass over volume, so para masagot natin yung value ng mass, gagawin lang natin, cross multiply lang natin itong dalawa na to. Okay, yung density at saka volume. So, therefore, the mass is equal to the density times the volume. So, that's 150 kilograms per cubic meter times 0.02 cubic meter. So, if you notice, makakancel na yung unit dito na cubic meter, kaya matitiran ka lang ng unit na kilograms. So, therefore, the mass of the spherical metal ball is 3 kilograms. So, again, kung ilalagay natin ito sa tubig, lulutang ba to? Yes. Okay, lulutang siya kasi ang kanyang density is 150 kilograms per cubic meter, which is less than the density of fresh water, which is 1,000 kilograms per cubic meter. So, another concept na inaaral natin sa fluid statics is the specific gravity. So, the specific gravity is defined as the ratio of the density of the substance to the density of the water. So, in equation form, we have this. So, density of substance divided by the density of the water. So, remember na walang unit ang specific gravity. Bakit? Kasi makakancel yung units nila dahil parehas tong density. So, para makuha ang density ng object, pero given ang specific gravity, madali lang. So, ang gagawin lang natin, i-multiply lang ang specific gravity sa 1,000 kilograms per cubic meter, which is the density of pure water. Remember, ang pinagbabasihan dito ay pure water, hindi salt water. Okay, let's have an example. The specific gravity of salt water is 0.25. So, what is the volume of 20 kilograms of salt water? Okay. So, since given ka rito ng specific gravity ng salt water, so, ang gagawin lang natin, susulat muna natin lahat ng given and unknown quantities natin. So, the specific gravity or SPGR is 1.025. You have a mass of 20 kilograms. And we're asked to find for the volume of the water. Okay, so compute muna natin ang density given the specific gravity. So, di ba kanina sabi ko, para makuha mo yung density, i-multiply mo lang naman siya sa 1,000 kilograms per cubic meter. So, here you have 1.025 times 1,000. So, you'll get 1,025 kilograms per cubic meter. And then, para ma-compute naman yung volume, gagamit tayo ng density equation. So, we know that the density is equal to mass over volume. Kaya, para ma-solve ang volume, anong gagawin? So, simple lang, paglilipatin lang natin ng position si density at si volume. So, we have this. Ayan, volume is equal to mass over density. Now, kung substitute natin siya, so we have the volume is equal to 20 kilograms divided by 1,025 kilograms per cubic meter. Again, if you notice, makakancel yung unit ng kilogram, kaya may iwan ka na lang ng unit ng cubic meter. So, therefore, the volume is equal to 0.02 cubic meters. Now, one of the instruments na ginagamit natin to measure the specific gravity is the hydrometer. So, it is usually made of glass with a lead shot to weigh it down. And the red material above the lead is the wax. So, we use this in all sorts of industries dealing with liquids. Okay, so, ito yung ginagamit na instrument kapag kailangang i-measure kung tama na ba yung fermentation ng, let's say, ng wine, okay, or ng beer. Gumagamit sila ng hydrometer kasi, di ba yung, let's say, yung wine, pina-ferment siya. So, yung density ng fermented grapes, kasi actually fermented grape juice lang siya. So, iba yung density ng fermented grape juice doon sa actual ng grape juice. And for different types of wine, iba-iba rin yung kanilang specific density. So, di ba yung fermented wine, iniimbak natin siya. So, after some time, kapag on a specific period, so let's say, kunwari, after 3 years, okay, titingnan na ng distiller kung yung bang wine na ginagawa niya is tamang-tama na. So, ang gagawin niya, gumagamit siya ng hydrometer para i-measure yung specific gravity nung wine na kanyang ginagawa. So, the scale indicates basically the specific gravity of the liquid for the hydrometer. Now, sa barko, meron tayong tinatawag na plimsoll line. So, the plimsoll line, ito yung ginagamit natin na guide sa barko para sa loading. So, may makakita kayo ng different symbols, okay, dito sa plimsoll line. Nakasulat to usually dito sa gilid ng barko, okay. So, dyan malalaman kung yung barko ba is overloaded or pwede ka pa mag-load. So, may mga meanings yung bawat symbol na to. So, itong mga symbols na to actually represents the different types of waters. So, for example, ito. The TF here represents tropical freshwater. F here represents freshwater. The T here, this is the tropical line. And then S here is for the summer line. And then W here is your winter line. And then W and A represents the winter North Atlantic line. Now, based dito sa plimsoll line, actually, naka-arrange to na parang sa hydrometer, na naka-arrange siya according to the density of the type of water. Kasi, kahit na pare-pareha salt water yan, for instance, magkakaiba pa rin yan ng density. Kasi ang density ng salt water, for instance, ay nakadepende sa dami or concentration ng salt na makikita nyo dun sa seawater. Ganun din sa freshwater. Halimbawa sa river, iba yung, although sasabi natin na freshwater siya, pero pag halimbawa, let's say, mas polluted yung river or mas maraming minerals na makikita dun sa river, iba pa rin yung kanyang density. So, pwede siyang mag-increase. Okay? The more impurities that you add to the water, mas tumataas yung kanyang density. So, in this case, dito naman sa plimsoll line, sinasabi natin na itong tropical freshwater, ito yung pinaka-less dense, okay, or least dense of all the types of waters at the sea. Bakit? Kasi itong tropical freshwater, ibig sabihin, mas mababa yung, pinakamababa yung density nito kasi nandun siya sa mga areas na mahiinit, sa mga mahiinit na lugar. Kasi kapag mas mataas ang density natin, mas mababa yung temperature ng object. Now, in this case, ang nasa pinakamababa na level is itong winter North Atlantic. So, ito naman ay nasa pinakababang level kasi ito yung may pinakamataas na density. Okay? Kasi ang winter North Atlantic water, siya ng pinakamataas na density kasi yan yung coldest. So, di ba sabi ko kanina, kapag mas mababa ang temperature mo, mas mataas din ang iyong density. So, sa barko, yun yung usual na ginagamit na guide for determining kung dapat pa bang maglagay ng load ang barko o dapat pa bang hindi na. Okay? Kasi this one acts like your hydrometer on board. Now, another concept that we discuss also in fluid statics is the pressure. So, in general, the pressure is defined as the measure of the force exerted per unit area. So, meron tayong mga common conversion factors dito. Okay, so you have the unit of Pascal is the common unit that we use for pressure. So this is equivalent to Newton per square meter. Okay, so or it's also equivalent to 0.021 pounds per square foot. Okay, so another example na ginagamit din madalas sa pressure is the PSI, which is the pounds per square inch. Another unit that we use is the mmHg, or the millimeters of mercury. And then, ito pala yung ATM means atmospheric pressure. So, this is the amount of pressure that is exerted by the atmosphere, which is equivalent to 101.3 kilopascals. So, kung gagamitin natin yung formula ng pressure. So, pressure is equal to F over A. So, that is the force over area. Now, if you notice, the force here is directly proportional to the pressure. So, meaning, kapag mas mataas ang value ng force, mas mataas din ang value ng pressure. Kapag mas mababa ang value ng force, mas mababa rin ang pressure. But the pressure is inversely proportional to the area. So, yung area natin, let's say mas mababa siya, mas tumataas naman ang ating pressure. So, they are inversely proportional. Okay, now let's look at this example. Very common dito makikita minsan sa mga magic shows na sinasabi na magic show na nakakahiga yung person sa bed of nails pero hindi siya nasasaktan. Actually, it's scientific, so hindi siya magic. Okay, why? Okay, so i-consider natin ang ating formula for pressure. Okay, anyone can survive the bed of nails because there is very little pressure on the tip of the nail. So the weight of the person is distributed over many nails. Yung force ng person na to is actually equivalent to his weight. Okay, so yung buong weight niya babagsak dito sa bed of nails. Now, since ang area mo is malaki, okay, hindi lang kasi isang nail yan magkakadikit na nails yan. So, pag pinagsama-sama mo yung cross-sectional area ng mga nails na to, malaki yung magiging value ng iyong area. Kaya, based ito sa equation, kahit malaki ang force mo, pero kung malaki din ang area mo, ibig sabihin, maliit lang ang iyong pressure. Because remember, the area is inversely proportional to your pressure. Now, paano kapag isang nail lang yan? Ngayon, kung isang nail lang yan, siguradong tusok ka talaga, masasaktan ka. Kasi, di ba, napakalaki ng force mo, pero yung area mo is napakaliit. Okay? Kaya mataas yung pressure. Kaya it can cause piercing through the body. Kaya di ba minsan ba pag naka-apa ka ng bubog, kasi yung buong weight mo naka-pressure lang or nakapatong lang doon sa isang maliit na cross-sectional area ng bubog. Kaya minsan yung bubog, di ba, bumabaon sa skin natin. It's because of this. Because you have very small area wherein your force acts upon, kaya mataas yung ating pressure. It's the same thing with the knives. So, mapapansin yung mga kutsilyo natin, bakit natin kailangang hasain? Okay, bukod sa, sinasabi natin sa Tagalog, kasi mapurol na siya, hindi na siya makahiwa. Hindi na siya makahiwa kasi hindi na effective yung kanyang pressure. Kasi, bakit? Kasi kapag hindi na yan nahasa, kumakapal na diba yung edge niyan. So, kumakapal na yung edge ng knife mo. So, kailangan mo siyang panipisin. Bakit mo kailangan panipisin? Pinapalit mo actually yung area. Para kapag kahit gumamit ka lang ng small force, ang gamitin mo dun sa knife, mag-create ka ng large pressure na para mas madaling makahiwa kung saan mo man siya gagamitin. Okay, so let's have an example here. So, 2 bicycle tires are filled with a pressure of 1.5 times 10 to the 4th Newton per square meter each. Each tire has an area of 0.5 square meters in contact with the ground. So, what is the weight of the bicycle? Okay, so susulat muna natin again lahat ng given natin. So, you have a pressure of 1.5 times 10 to the 4th Newton per square meter, and then you have an area of 0.5 square meters, and you have the value of the force is the unknown value. Okay, pero sabi dito weight ng bicycle. Remember that weight is actually gravitational force. Okay, so first, i-compute muna natin ang force from the pressure equation. So, given the pressure equation, diba, you have F over A. So, para ma-solve mo ang force, ano lang gagawin natin? Simply cross-multiply the pressure and the area. So, F is equal to P times A. So, when we substitute that, so you have 1.5 times 10 to the 4th Newton per square meter times 0.5 square meter. So, if you notice, makakancel natin yung unit na square meter, kaya matitiran ka na lang ng unit na Newton. So, here you have 7,500 newtons for the force. Pero remember, this one is only for one tire. Okay? Kasi yung given na pressure nito, di ba sabi, each So, per tire to. Pero meron kang dalawang tires. So, ang gagawin lang natin, i-multiply lang natin yung nakuha natin na value ng force by 2. So, therefore, the total force is 15,000 newtons. So that is equivalent to the weight of the bicycle, 15,000 newtons. Okay, another example. So a cube has edges of 3 meters long. How much pressure does it apply to the floor if it has a mass of 200 kilograms? So, gagawin lang natin again, sulat natin ang given and unknown quantities. So, you have the side of each cube is 3 meters. And then you have the mass of the cube, which is 200 kilograms. So, we're looking for the value of the pressure. So, i-compute muna natin yung area ng cube since given ang side. So, ang area ng cube would be S squared. Kasi, di ba, ang cube is actually a square, yung surface area niya. So, you have 3 meters square, so that's equivalent to 9 square meters. So, next, i-compute naman natin ang force gamit yung mass. So, ang force ay equivalent sa weight, which is Fg. So, let's remember na para ma-compute yung value ng weight, so that's mass times the acceleration due to gravity. So, here you have 200 kilograms times 9.8 meters per second squared, which gives you 1,960 newtons. So, next, i-compute na natin yung pressure. So, since the pressure is equal to force over area, so that's 1,960 newtons divided by 9 square meters. So, you have 217.8 pascals. So, yung newton per square meter equivalent niya ay pascals. So, therefore, the cube applies a pressure of 217.8 pascals on the floor. Okay, next, let's have the liquid, or we also call this as the gauge pressure. Now, yung liquid pressure, this is the pressure obviously exerted by a liquid. So, the pressure is directly proportional to the density of the liquid. And it is also directly proportional to the weight of the liquid column. So, in equation, you have this. The pressure is equal to rho GH. Okay, rho is the density of the liquid. G is the acceleration due to gravity, which is equal to 9.8 meters per second squared. And then you have H, which is the height of the liquid column. Or sometimes we call this as the depth of the liquid. Okay, so based dito sa illustration natin, ito yung tinatawag natin na height of the liquid column. Okay, now another example or another term that we will also encounter is the absolute pressure. So this is the pressure exerted by the liquid and the atmosphere. So pag sinabi natin absolute pressure, ina-add lang naman natin yung atmospheric pressure, which is P sub O. So here, the total pressure can be computed by adding P sub O, which is the atmospheric pressure. We will add this to the pressure exerted by the liquid or the liquid pressure. Yan. So, ito yung value ng P sub O natin. The atmospheric pressure is 1.013 times 10 to the 5th pascals. Wherein you have here, the rho is the density of the liquid, G is the acceleration due to gravity, and H is the height of the liquid column. Now, if we will look at the concept of liquid pressure, sabi dyan, the pressure of the liquid is the same at any given depth below the surface regardless of the shape of the container. So, for example, meron tayo ditong dalawang fish and it's moving at an aquarium that has this kind of shape. So, if you notice, same lang yung water level, okay, ng dito sa container. So, therefore, yung liquid pressure na na-experience itong fish na to, okay, na nandito sa side na to is also equal to the same liquid pressure experienced by this fish here. Kasi again, same lang yung kanilang water level. Magkakaiba lang yung liquid pressure nila kapag yung isa ay mas mataas o yung isa mas mababa ang water level. Now, let's have an example. So, what is the total pressure 5,000 meters below the surface of water? Okay, so here, we will again write the given and unknown quantities. So, you have a height, or ito yung height ng liquid column, or ito yung depth natin. So, that's 5,000 meters. And then, we're asked to find the total pressure. Okay, so total pressure to. So, note na ang ibang values ay constant. So, katulad ng atmospheric pressure, density of water, at acceleration due to gravity. So, i-assume natin dito na fresh water yung pinag-uusapan natin. So, itong mga constants na to, Ito yung sinasabi ko sa inyo na dapat madalas yung tandaan kasi madalas yung siyang gagamitin sa mga problems. So, kukumpute natin yung total or yung absolute pressure. So, which is equal to P sub O plus rho GH. So, if we will substitute, so 1.013 times 10 to the 5th pascals, this is the atmospheric pressure plus 1,000 kilograms per cubic meter, which is the density of pure water, times 9.8 meters per second squared acceleration due to gravity times 5,000 meters. So, when we compute for this, so we will get the value of total pressure of 4.91 times 10 to the 7th pascals. Okay, another example. So, a submarine goes 10,000 meters deep into the sea. How much pressure does the salt water exert on the submarine? The density of salt water is 1,025 kilograms per cubic meter. So, in this case, sulit muna natin lahat ng given and unknown quantities. So, you have the depth of the liquid column, which is 10,000 meters. Then you have the density of salt water, which is 1,025 kilograms per cubic meter. And you have to compute for the liquid pressure. Okay, so yung liquid pressure natin is rho GH. So if we will substitute the value, so you have 1,025 kilograms per cubic meter times 9.8 meters per second squared times 10,000 meters. So you'll have liquid pressure of 1 times 10 to the 8 pascals. So this is the amount of pressure that the salt water exerts on the submarine. Okay, now the Pascal's principle. So sabi sa Pascal's principle, any change in pressure applied to a completely enclosed fluid is transmitted undiminished to all parts of the fluid and the enclosing walls. So ibig sabihin nito, kung meron kang in this case, meron kang contained fluid. Sabihin, nakalagay siya sa isang container, tapos confined lang siya. So, walang labasan yung hangin. So, talagang siya lang yung nandito. And sealed ito. Okay? So, kapag nag-exert ka ng pressure on one side, okay, yung pressure sa buong liquid is actually the same on all other sides. So, kasi sinasabi natin dito, P sub 1 is just equal to P sub 2. Now, using this, we can have the following. So, you have, since the pressure is equal to F over A, so you have your F1 over A1 is equal to F2 over A2. Ito yung principle na ginagamit sa mga hydraulic lift. So, P1 here is the input pressure, P2 is the output pressure, F1 is the input force, F2 is the output force. Area 1 or A1 is the area where input pressure is applied, and A sub 2 is the area where the output pressure is applied. So, ganyan yung principle ng hydraulic lift. So, this is a device that uses a confined fluid to transfer fluid pressure from one platform, the input, to another, which is the output. So, this is your input. Okay, and then this is your output. So, ito yung mga ginagamit sa mga, mga repair shops, sa mga, sa mga repair shops, sa mga cars, or even in the huge manufacturing industry. So, gumagamit sila ng hydraulic lift to lift heavy objects using the principle of Pascal. So, let's have an example here of Pascal's principle. So, Jenny's favorite ride at the Barrel of Fun Amusement Park is the flying umbrella, which is lifted by a hydraulic jack. The operator activates the ride by applying a force of 72 newtons to a 3 cm wide cylindrical piston, which holds the 20,000 newton ride off the ground. So, what is the diameter of the piston that holds the ride? Okay, so again, susulat muna natin lahat ng given and unknown quantities. So, you have the input force, which is 72 newtons. And then you have the diameter, okay, input diameter, which is 3 centimeters. And then output force is 20,000 newtons. So, we're looking for the value of this one, of the D2. So, dahil diameter ang given sa problem, pwede nating i-derive ang equation ng Pascal's principle na gamit ang diameter. So, gagamitin muna natin yung area ng circle. Now, remember na piston to, cylindrical piston. So, ang cross-sectional area ng isang piston is actually equivalent to a circle. So, kung circle siya, ang area ng circle is pi r squared. Pero dahil dito, given ang diameter, so papalitan lang natin dito yung r ng d over 2. Okay, or the diameter divided by 2. Kaya dito, magiging pi. Okay, and then yung d over 2 is square natin. So, ito na ngayon yung magiging equation for finding the area using the diameter. So, that's d squared over 4 times pi. Kasi di ba ito magiging d squared, ito magiging 2 squared. So, that's why it's 4. Okay, next is substitute natin ang formula ng area sa Pascal's principal equation. So, ito yung Pascal's principal equation natin. So, we have F1 over A1 equals F2 over D2. So, gagawin lang natin, papalitan lang natin yung A dito ng equation na to. Okay, for the area of the circle. So, you have this. So, F1 over D1 squared over 4 pi. And then, F2 equals F2 over D squared over 4 pi. Okay. Now, if you notice, ito kasi same lang siya, yung over 4. So, pwede natin siya i-cancel. Pati yung itong pi, pwede natin i-cancel kasi parehas lang siyang nasa both sides of the equation. So, cancel na yan. So, pag sinimplify natin yung equation, you can only have F1 over D1 squared equals F2 over D2 squared. Okay, so using this, okay, gagamitin na natin to sa pag-derive ng formula for finding d sub 2. So, paano gagawin? Cross-multiply muna. Okay, pag na-cross-multiply natin to, so in this case, cross-multiply natin yung d1 squared sa f2. So, ito yon. And then, itong dalawa maka-cross-multiply. And then, after that, we divide both sides of the equations by f1. Yan. Kaya ganito yung nangyari sa kanya. So, therefore, to find the value of d, kukunin lang natin yung square root ng both sides of the equation. So, d2 is equal to the square root of f2 d1 squared over f1. So, if we want to substitute, we have the following. So, that's the square root of 20,000 newtons times 3 centimeters squared over 72 newtons. So, if you notice, maka-cancel yung unit ng newtons dito. Kaya, maiwan na lang dito ay centimeters. So, therefore, the diameter of the piston is 50 centimeters. Let's look at another example. So, you have here a 2,000-pound car is lifted by a manually operated hydraulic lift. The area of the shaft of the lift is 80 square centimeters, and the area of the piston that forces liquid into the system is 2 square centimeters. What force must be exerted on the piston to lift the car? So again, sulat muna natin yung unknown at given quantities. So you have the input force for F1 is 2,000 pounds. A1 is 80 square centimeters. So, we're looking for F2 for the area or A2 of 2 square centimeters. Now, susolve na natin ang F2 using Pascal's principle. Now, kailangan ba nating mag-convert ng units? Actually, hindi na. Kasi consistent naman siya. Parehas lang naman siyang centimeter dito. Kailangan mo lang mag-convert ng units kapag, let's say dito, hindi magkaparehas yung unit ng area. Okay, so solving for F2, so pag translate natin itong equation na to, so i-cross multiply muna natin itong dalawa. So F1, A2, and then divide this by A1. And when we substitute, so you have 2,000 pounds times 2 square centimeters divided by 80 square centimeters. So makakancel yung unit ng square centimeters and you're left with F2, which is 50 pounds. So, therefore, the force that must be exerted on the piston must be 50 pounds. And now, let's have buoyancy. Okay, so, buoyancy is the apparent loss of weight experienced by objects submerged in a liquid. So, for instance, diba, pag nagsiswimming tayo, kasi pakiramdam natin, parang mas magaang tayo sa tubig. Okay, so parang, in a way, parang feeling natin na bawasan yung weight natin. So, yun yung tinatawag dito na apparent loss, okay, of weight experienced by objects na nilalagay natin sa isang liquid. So, it acts in the opposite direction of gravity and causes an object to become lighter. So, kung ang direction ng gravity or ng weight natin is pababa, diba? Remember that gravitational force is always acting downward. So, ang direction naman ng buoyancy is parating pataas. Okay, it is always opposite to the direction of gravity. Now, the buoyant force is the upward force exerted by a liquid when an object is immersed to it. So, all objects when placed in a liquid experience buoyant force. So, lahat ng object basta nakalagay siya sa liquid, meron siyang buoyant force. Now, yung buoyant force na yun, it is also, again, acting opposite to the direction of gravity. So, therefore, the buoyant force is always directed upwards. So, for instance, kapag, let's say, nasa pool ka, okay? So, the water exerts a buoyant force on you, which is directed upwards. So, kaya this is the reason why you feel lighter when you're in the pool, because the water exerts a buoyant force on you. Now, yung buoyant force also has something to do with flotation. So, katulad kanina, yung density, di ba, may kinalaman din siya sa flotation. How? Kapag yung weight ng object or the Fg, okay, the weight of the object is greater than the buoyant force, ano mangyayari? The object will sink. Okay? So, note that the Fg as the gravitational force. Inuulit ko ha, yung weight hindi siya yung mass. Hindi siya yung bigat na tinatawag natin sa Tagalog. Kasi sinasabi nating bigat sa Tagalog, that is equivalent to the mass. Pero dito, this is weight. So, we're discussing about force. So, the weight is equivalent to your gravitational force. So, we can compute for the Fg by using mass times the acceleration due to gravity. Now, what about if the weight of the object is less than your buoyant force? So, kapag ganyan, when the weight of the object is less than the buoyant force, the object will float. And if they are equal, okay, pag equal naman yung weight ng object to the buoyant force, obviously, the object becomes fully submerged. So, parang very similar lang siya dun sa density. Okay, yung principle ng density. Di ba sabi ko nga kanina, walang kinalaman yung bigat ng object doon sa paraan niya ng paglutang o paglubog. Now, finally, let's look into Archimedes principle. Okay, sabi sa Archimedes principle, any object completely or partially submerged in a fluid experiences a buoyant force, which is given by the symbol Fb, equal in magnitude to the weight of the fluid displaced by the object. So, in summary, we will put that into an equation. Ito siya. So, the buoyant force is equal to the mass of the fluid that was displaced, diba? Force is mg, diba? So, parang, or MA. So, in this case, ginagamit natin yung mass ng fluid times the acceleration due to gravity. Pero since alam natin na yung mass ng fluid, hindi mo naman kasi ma-measure yung mass ng fluid. Mahirap yun. Pero, pako-compute natin ang mass by using the density equation. Diba yung density is mass over volume. So, para ma-compute natin yung mass, i-multiply lang natin yung density at yung volume. Kaya itong rho V, actually, ito yung equivalent ng M dito. Ayan, galing sa density equation. So, we can also write the buoyant force as the density of the fluid times the acceleration due to gravity times the volume of the displaced fluid. Okay, let's have this illustration here. So, first case, so let's say you have here an object na nakahang and it is hanging or suspended in air. So, the mass of the object is 5 kilograms. Okay. Now, kapag yung object na to, nilagay mo siya sa tubig, okay, and when you say it is fully submerged, yung the water here will exert a buoyant force on this object. Okay, so technically speaking, ito dito na makaka-experience yung object ng apparent loss of weight. Okay, so bababa yung kanyang weight. Okay, so yung syempre dito kung sasahurin natin yung water na mag-overflow, yung space na dating ino-occupy ng water, pinalitan nitong object nito. Kaya yung water na yun na pinalitan ng object nito, okay, ang tawag doon is a displaced water. Okay? Now, yung weight ng object na yon is actually equal to the displaced water. Or in some cases, we can also say na yung volume na na-displace nitong object na to is also equal to the volume of the displaced water. Okay, so in this case, if the object is fully submerged in the water, the buoyant force is equal to the weight of the displaced water. Now, remember this, that the buoyant force is equal to the weight of fluid displaced. So, yun yung pinakasimpleng paraan para maisip nyo kung ano yung buoyant force. It is always equal to the weight of the fluid displaced. So, kumbaga, yung dating liquid o yung dating fluid na nandito, pinalitan lang siya ng object. Okay? Kaya yung na-displace na yun, that is equivalent to the buoyant force exerted by the fluid or by the liquid. Now, for instance, if the ship sinks into the water, it displaces more water. So, the volume of the displaced water is equal to the volume of the part of the ship that is underwater. Okay, for example, dito sa case na to. At this level, okay, so obviously, merong volume tong ship, diba? So, yung volume na to, okay, na na-occupy ng ship na underwater, kung ano man yung volume na to, that is actually equal to the volume of the displaced water. And if you notice here, so mas mababa yung level ng ship dun sa water, just like in this case, on the second ship, di ba? Mas mababa siya yung paglubog niya kaysa dito sa first ship. So, pagdating dito, we can say that the volume of the displaced water here is greater than the volume of the displaced water here on the ship. So, pwede natin sabihin dito na bakit medyo bumaba yung level niya kasi nag-add ka na ng load. Okay, so the more that you add load to your ship, mas lalong tumataas yung volume of displaced water. At kapag mas tumataas to, ibig sabihin, mas tumataas din yung buoyant force na kailangang exert ng water sa'yo. So let's remember some important points that you need to consider when solving Archimedes principle. So for an object that is fully submerged, we can say that the volume of the displaced fluid is just equal to the volume of the object. Again, kapag fully submerged, ibig sabihin itong buong object na to is completely underwater. So kung ano man ang volume ng rock na to, for instance, okay, yun din yung same volume ng na-displaced na fluid. And the weight of the object is also equal to the buoyant force. Okay? Kapag, again, completely submerged ang object mo, the weight of the object is equal to the buoyant force. Now, another way to compute for the buoyant force is this. Ang gagawin lang natin, isusubtract lang natin yung weight ng object kapag nasa air siya. Sabihin, wala pa siya dun sa water, minus the weight of the object kapag nandun na siya sa water. Kasi diba, banggit natin na kapag nilubog mo na yung object sa water or in any other fluid, bumababa yung kanyang weight. Okay? So, ang gagawin mo lang para mo-compute ang buoyant force, simple. Isusubtract lang natin yung dalawang weights na yon. Weight of the object in air minus weight of the object in water. Now, let's try to apply that in an example. So, calculate the buoyant force on a rock of mass 32 kilograms and density of 2,800 kilograms per cubic meter when fully submerged in water of density 1,000 kilograms per cubic meter. Okay, so again, susulat muna natin yung mga given. So, sa pagsulat ng given at unknown, mas maganda nagmumuha tayo ng dalawang column para mas madali nating matrace kung sa object ba or sa liquid yun. Kasi kung minsan, ang problem dito is nalilito na kung ano yung value ng gagamitin, kung yung ba yung sa object, yung ba yung sa liquid. So, tatlong given lang naman yung kailangan nating ilagay dun sa table. So, yun yung mass, yung volume, at yung density. So, let's look at this example. Ayan. So, dito, given ng mass ng rock, so that's 32 kilograms. And then, meron tayong ditong given na 2,800 kilograms per cubic meter, which is the density of the rock. So, hindi natin alam kung ano yung volume ng rock. Okay? So, yung sa water, hindi natin alam ang mass ng water, pati yung volume ng water. Pero, alam natin na ang water has a density of 1,000 kilograms per cubic meter. And then here you will find the value of the buoyant force. Okay, so from the formula for FB, hanapin muna natin ang available na given sa equation. So alam natin that the buoyant force is equal to rho F G V F. Okay. So, from the given, may density of the water at constant ang value ng G, pero walang given na VF. Okay? So, paano natin mako-compute yung VF? So, remember na yung object natin ay fully submerged. Okay? Fully submerged yung rock. Kaya pwede natin sabihin na yung value ng water, displaced water, is also equal to the volume of the rock. So, para ma-solve ang volume ng rock, anong gagamitin natin? Gagamitin natin yung density formula para sa rock. So, dito na tayo magpo-focus ng attention. So, the density of the rock is equal to mass over V. Okay? So, therefore, to compute for the volume, so pagpapalitin lang natin yung position ng density and ng volume. So, you have the volume is equal to mass over density. So, if we will substitute the 1 for the rock, kasi sinusolve muna natin yung volume ng rock. So, that's 32 kilograms divided by 2,800 kilograms per cubic meter. So, therefore, the value of the volume of the rock is 0.011 cubic meter. Pero, dahil sabi nga natin, fully submerged ang rock, ibig sabihin, same lang to ng volume ng displaced water, which is also equal to 0.011 cubic meters. So, next, isusolve natin ng FB using the formula. FB is equal to rho GV. Okay, so if we will substitute that, so this time, dito naman tayo magpo-focus sa water. So, you have 1,000 kilograms per cubic meter times G is 9.8 meters per second squared times the volume na nasolve natin kanina, that's 0.011 cubic meters. So, therefore, the buoyant force is 107.8 newtons. Okay, let's have another example. A 0.8 kilogram crown is submerged in water and its weight in water is measured to be 7.30 newtons. If the density of pure gold is 19,300 kilograms per cubic meter using Archimedes principle, determine if the crown is made with pure gold or not. Okay, so again, kailangan nating i-prove dito kung pure ba yung gold, kung pure ba na gold yung crown o hindi. So, para malaman natin kung pure to, kailangan muna natin isolve ang density ng crown at i-compare ito sa density ng pure gold. So, again, gagawa muna ulit tayo ng dalawang column para sa crown and sa water. Okay, so ito yung given natin. So, ang given sa crown, ito 0.80 kilograms. And then sa water, ang given ay ito, yung density ng water na 1,000 kilograms per square meter. So, hindi natin alam parehas on both sides. Yung sa crown, hindi natin alam yung volume ng crown saka yung density ng crown. And then for the water, we don't know the mass of the water and then the volume of the water. So, pero dito, meron pang isang paraan. Okay? Given tayo dito ng mass sa water. Okay? Ito yung mass ng crown sa water, which is 7.30 newtons. Okay? So, using this, pwede nating makompute yung magiging buoyant force. So, how can we do that? So, dahil given ang weight ng crown sa water, okay, pwede natin gamitin itong formula na to. Okay, so the FB is equal to the weight of the crown in air minus the weight of the crown in water. So, para makuha natin ang weight of the crown in air, gagamit tayo ng formula ng weight, which is Fg. So, gagamitan natin siya ng mass times acceleration due to gravity. Kasi given naman tayo ng mass ng crown. So, that's 0.8 kilograms times 9.8 meters per second squared. So, we'll get a value of 7.84 newtons. Ito ngayon yung gagamitin natin para isolve yung FB. So, using this to solve for FB, so you have the weight in air, which is 7.84 newtons, minus in the given, you have the weight in water, 7.30 newtons. So, you'll have a buoyant force of 0.54 newtons. So, from here, gamitin pa ang isa pang formula for FB para makompute naman this time yung volume ng water. So, gagamit na tayo ng rho GV. Okay? So, para ma-solve natin yung volume, Okay? So, yung volume na makukuha natin, that's equal to FB over rho G. So, that's 0.54 newtons times 1,000 kilograms per cubic meter times 9.8 meters per second squared. Remember, kaya natin to kailangan i-compute kasi alam natin na yung volume ng displaced water is parehas lang sa volume ng crown. So, therefore, the volume of the displaced water and the volume of the crown is equal to 5.5 times 10 to the negative 5 cubic meters. So, ngayon, isosolve na natin ang density ng crown since meron na tayo nito. Ayan na siya sa given natin using the density equation. So, we have mass times the volume, so that's 0.80 kilograms divided by 5.5 times 10 to the negative 5 cubic meters. So, that's equal to 14,545 kilograms per square meter. So, is this crown made of pure gold? No. Kasi ang density ng pure gold is 19,300 kilograms per cubic meters. So, in short, peke yung crown. So, since the density of the crown is only 545 kilograms per cubic meters, therefore, the crown is not made of pure gold. So, now that you have finished lecture 4, assuming that you have also finished lecture number 3, so you can now try to work on output quiz for level 14, which is part B. Okay, this is again an open note quiz. So, make sure na you have your notes with you and you have your calculator kasi most of the questions here requires solutions. So, you can also refer to your notes para masagutan yung mga concepts. So, consider this as a mock exam kasi kung ano naman yung content nito, similar din kasi yung style niyan dun sa may encounter nyo sa final exam. So, since wala tong time pressure, it's a very good way to practice kung naiintindihan nyo ba talaga yung concept or hindi. If you need further assistance, just contact your respective Gymathics instructor using their Facebook accounts.